My presentation with a little mental experiment, which for some of you won't be too difficult because some of you went on a boat cruise last night. I want you to picture yourself on the boat, and you've been lucky enough to find yourself stood next to a prominent researcher in the field, let's say it's Michael Turvey, and you accidentally say, well, I saw your presentation on strong weak anticipation and I wasn't convinced at all. Or you could even say something even worse, such as, I don't think Arsenal are going to win any trophies this year. And he gets very angry and upset, and he pushes you off the boat. And because he's so mean and nasty, he also goes to the driver and says, we're going to drive this boat away as fast as possible. And you're now left in this situation. So you're in the water, you don't have anything around you, and you have to decide, well, what am I going to do from here? I'd like you to play this mental experiment with me. So every one of you in the room has to decide how far you think it is to that little white shed on the shore.
An hour?
Just looking at this picture. So if you've got a pen and a paper, write it down. You could write in meters, or if you're stuck in an attractor state that says, I have to write in yards, you can do it in that as well. Okay, so how far is the shed? Or how far is the shore away? Everyone done that? Good, because that's exactly what we did with the participants in the study that I'm about to describe. And we'll come back to the answer in a little while. Am I plugged in? So just a little bit of background information for you. In terms of perceptual space, and research has been done on this, and it's identified that there are, broadly speaking, 3 different areas. Much more research has been conducted, as we've heard actually in the last couple of days, on this idea of personal space, where reachability, stepability issues have been examined, and also the action space between 2 to approximately 30 meters, where you might typically be able to traverse that distance. But less research has been conducted on greater distances and vista space. What we found in the few studies that have been conducted is that when people are asked to make estimates of distance under 100 meters, they typically underestimate that distance. If it's over about 100 meters, it seems that they make overestimates. And the further away you get from 100 meters, the greater that overestimate. This research has been typically conducted in the military, or certainly over land, rather than over water. So we were interested in obviously whether some of these findings transferred to the open water situation. Of course, we know, largely because of Dennis Proffitt's work, that our ability to estimate distance is dependent on other things, other factors, and one of them might be the combination of our ability to traverse the distance, our action boundaries, as well as the amount of effort or perceived effort that it might take to traverse that distance. And again, one of the reasons we really wanted to look at this open water situation was if you remove all the contextual cues, or just have water in front of you and nothing else to give you indication of how far it might be, what does that do to your ability to estimate distance? The small body of literature we have found is, has examined this situation just as you were presented by looking at a large screen, and showed that people were much more variable in terms of their estimates when they were watching a screen. And in fact, most of their estimates, as the vista space research would suggest, were overestimates, and it could be up to over 230% off of the actual distance. Okay, so again, if you're stuck in the water, like Turvey and his friends are in the boat rocketing away, and you're making an estimate that you've got to swim, say, 600 meters, whereas in actual fact it's maybe only 300 meters, then that's obviously an important feature. We need to understand why that's the case. So we took 40 students who were actually engaged in an aquatics program, so they were required to do an open water swim as part of this program anyway. And we took them into the Otago Harbour. This is Dunedin here in the New Zealand South Island, and you can see this lovely peninsula here. My home, by the way, is just here, so I get to look out on this every morning. And we took them from a boat around about here out into the harbour, and that the width of that peninsula is about just over 1 kilometre. So we can take them, if needed, to be up to 1 kilometre away from the shore. And we stopped the boat at numerous points in this trip, and we asked them to, as you have been asked, to estimate the distance. And of course the boat had GPS with us, so we could identify exactly how far we were away. When they reached the distance which they thought they were really going to struggle to be able to swim back, we then dropped them into the water and asked them to tread water for 2.5 minutes. And water, as you can see up here, wasn't particularly warm, so they had to factor that in as well. We asked them, what's the distance, how long do you think it's going to take you, and how confident are you that you're going to make it to be able to swim back unassisted? And then, just because of the old problem of ethics, we had to follow them back with a boat rather than leave them to it, which was a bit of a shame. So, rapidly into the data, individual data here. So, if they were making perfect estimates, they would be falling along this line, because this is the distance, the actual distance, as against estimated distance. And you can see there's a lot of variability around this line. So, again, that was partially expected because of the previous research we've been looking at, in both land and over water. And the people, if they were making consistent underestimates, would be stuck under this line, and overestimates. So you can see, again, there's a lot of individual variability. Some were making overestimates, and some were making underestimates. And this is average data across the different ranges. Is it related to their swimming ability? So we actually had data related to how good they were swimming in a pool. And the size of these circles indicate that the better swimmers in the pool. And again, we were interested in, well, is there a consistent pattern? Do the better swimmers, who might perceive this as less effort possibly, do they make underestimates? But well, that doesn't appear to be the case as well. As you can see, there's still a fair bit of variability in here. And here we have males and females separated, but again, no gender-related effects in our statistics. So, is there a general overestimate, as the data has suggested? Well, yes, but it's not particularly big, as you can see. When you average this out, the overestimates, and they were certainly nowhere near the regions that we were finding overall, although certain people made really large overestimates, over 200% here, or just about. But on average, this worked out to be only just over about 6% overestimate. So they were actually reasonably accurate when you averaged them all out. But of course, if you're in this group making these really large overestimates, or even down here, making these really large underestimates, then you're still quite inaccurate. So we also did a manipulation study where we took them back into a room afterwards and showed them some pictures as you've been shown, and we asked them to estimate the distances of these pictures. And again, you have the actual distance here, so here was one just under 100 meters, and the actual estimates they gave. So again, you can see some underestimates here, a lot of underestimates here, but then people start to overestimate as it goes away. So this phenomenon that we're finding in the literature does seem to exist. And also, as you can see from the blue square here, they are much less accurate when they're looking at a screen image versus when they're in the water themselves. So, no study is perfect, as I'm sure everyone in the room knows, and there's lots of things we'd like to do. The availability of a target or something to swim towards seems to be really important, so having that shed there seems to be necessary, something for them to fixate on to actually swim towards. Because they're making an impending action, we do think that the influence of jumping into the cold water is again potentially making estimates less accurate. So we're going to include a condition this year where they're taking out on the boat but not actually put into the water, and see if that helps. We think that, of course, they're probably getting cues as the boat drives out into the distance in terms of how far away they might be. So one thing we're deciding right now is whether we randomize the order in which they're asked to make those distance estimates. Now, I think we need to test over a greater range, because the boat typically only went 300 to 400 meters, which is, I think, the distance away from the shore that many of you were last night, apparently. And the level of risk, and I'm not sure what we can do with this, but I think that's important, because people do tend to make bad decisions when they start to panic. So they're in the water and there's nothing around them, and then they might choose to swim when perhaps it wasn't the best decision they could have made. So we're talking with our ethics approval people about whether we can do something a little bit more along those lines. So in summary, what do people do? If this is you and you're in a boat and all of a sudden you fall out into the water's cold and you're looking at the shore and you're thinking, well, can I make that distance? In our study, it seems to be the case that people either overestimate or underestimate the distance. But they actually can swim further than they think they can. So almost all of our participants made it back to the shore, you'll be glad to hear. Only 3 didn't, and the boat was, of course, right next to them and picked them up. They did it less time than they thought. I haven't presented that data here. But they were also much more accurate than we expected, although, again, the individual variability in this data is really noticeable. So, how far did you say?
6 minutes.
6 minutes? Okay, so the distance was 278 meters. So well done if you were close. And luckily my turvy was, so that's good if you got pushed off by him. And we're at the end of this symposium, but obviously, any brief questions for me, or if you wanted to ask questions and search me out, Ludovic's got a question. Thank you.
Thank you, Chris. Do you have any idea of what could be the effect of the water flow if you are in the sea and it's waving?
The harbour conditions were pretty still, and we chose those conditions because we didn't want that to influence us. We didn't want the tides to be changing between participants, for example. I would imagine that the waves would potentially add some context, which might be a good thing, but of course then that would add a more negative impact in terms of your decision to swim. So it's obviously well known that in choppy water it's a very difficult situation to then swim that distance. So no, we haven't done that. I guess we could do that potentially with the screen situation, but I'm not sure that we could control the water well enough to be able to replicate conditions for in the water. It's a good suggestion. There's lots of people who would love to ask me a question, but I know that we have another symposium and the chair's right next to me. So please feel free to come and ask us questions, and thanks for your attention for all the presenters, and I'm sorry for the next presenters for encroaching on your time. Thank you.